We're now going to generalize exercise 3 to the actual correct product rule. Remember, exercise 3 was when we were trying to figure out how we can add these and multiply them together to get the correct expression, and we found that it was some combination of the original functions and the derivatives of each of the pieces. And this is called the product rule, and the way I like to write it is that you first take, if you have the derivative of two things multiplied together, you take the derivative of the first one, multiply it by the second, plus the derivative of the second one multiplied by the first. That is the product rule right there. And it's very important. It's one of the formulas you will have to memorize in this class. So let's do an example here. H of x is equal to this thing times that thing. So we're going to use the product rule to do this. We're going to call the first function f of x and the second part of the function g of x. And if I take the derivative of that first thing, I just get 3x squared because the derivative of the 7 gives me 0. And if I take g prime of x, derivative of the second part, I just get 2x because the derivative of the negative 3 also goes to 0. So h prime of x, according to the product rule, is going to be f prime of x times g of x plus g prime of x times f of x. I know what f of x is, I know what g of x is, I know what f prime is and g prime is, so I just plug all those in. F prime is 3x squared, g of x is x squared minus 3, g prime of x is 2x, and f of x is x cubed plus 7. And this question doesn't say anything about simplifying it, but if we wanted to simplify it, we could multiply these through. 3x squared times x squared is 3x to the 4th. 3x squared times negative 3 is minus 9x squared. 2x times x cubed is 2x to the 4th. And 2x times 7 is 14x. So this actually, I can combine those like terms to give me 5x to the 4th minus 9x squared plus 14x as my answer. Now you won't always be able to do this, but for this particular question there's actually another way we can do this. In particular, we have a function here, h of x. If you didn't know the product rule at all, what you would do is you would first FOIL this out and get h of x equals x to the 5th minus 3x cubed plus 7x squared minus 21. And then I could take the derivative of this polynomial just like normal, 5x to the 4th minus 9x squared plus 14x, which gives me the same thing as I got over there. And in this particular instance, it's probably easier to multiply it out, but you won't always be able to multiply it out, and you'll have to use the product rule at some time, and that's why we need to know it. So let's do another example. This is one where you would not actually be able to multiply it out. Example 6 says, suppose your h of x function is square root of x minus 4x times some function g, and you don't actually know what g is. So here we have to use the general formula. We're calling that first thing f of x. Then h prime of x is equal to f prime of x times g of x plus g prime of x times f of x. And in particular, we want to find h prime of 9, which means I'm going to plug in 9 for x everywhere. So that's f prime of 9 times g of 9 plus g prime of 9 times f of 9. We don't know what the function g of x is, but we're actually given the value for g of 9 and g prime of 9. How about f prime of 9 and f of 9? Well, f of 9 we can figure out pretty easily. That's equal to, I'm just plugging in 9 here for x, so that's the square root of 9 minus 4 times 9. That's 3 minus 36, or negative 33. To find f prime of 9, I have to first find f prime of x. I have to take the derivative of this function. So f of x equals, I'm going to rewrite square root of x as x to the 1/2 power. then f prime of x is 1/2 x to the negative 1/2 power minus 4. And now, once I've taken the derivative, I can now plug in 9 to get 1/2 9 to the negative 1/2 power minus 4. 9 to the negative 1/2 power, that's the same thing as 1/3. So this is 1/2 times 1/3 minus 4. That simplifies down to being, so this is 1/6 minus 4 is the same thing as 24/6, so this is a negative 23 divided by 6. Okay, now we can plug all these things back in. F prime of 9 is negative 23/6. G of 9 is 6. G prime of 9 is 1/11. And F of 9 is negative 33. So those 6's cancel. I get negative 23. And then 11 goes into 33 3 times. So negative 23 plus a negative 3 is negative 26. I probably should have put more space in there for that problem to be worked. And now go ahead and pause the video and try to do exercise 7 on your own. Okay, so f of x here is x to the 5th plus 4. We're going to call, so here's a problem. This is already called f of x, and I'm used to calling this f of x and g of x. So I'll just, I can just change this f to an h, and then everything else will look nicer. So h prime of x will be f prime of x times g of x plus g prime of x times f of x. And I already know what f of x and g of x are, so let's take their derivatives. The derivative of x to the 5th plus 4 is 5x to the 4th. The 4 just goes away because it's constant. And g prime of x, the derivative of e to the x, is just e to the x. So this becomes 5x to the 4th times e to the x plus e to the x times x to the 5th plus 4. And that's h prime of x, but I want h prime of 0, so I need to plug in 0 everywhere that I see in x. E to the 0 plus e to the 0 times 0 to the 5th power plus 4. Well, this 0 to the 4th power will kill off that 5 and kill off that e to the 0, so that's just 0. E to the 0 is 1. 0 to the 5th power is 0 plus 4 is 4. So I get 4 as my final answer for exercise 7.